Welcome to Applied Security Engineering. In today's topic, we will be covering up the vulnerability which cause some of the biggest data breaches. And that vulnerability is not like SQL injection or cross-site scripting. It is like some of the biggest breaches happen because of one simple authorization mistake in an API. Yes, you got it right. It's broken object level authorization that can be called as BOLA. So in today's video, we will be talking about what BOLA is actually, why developer miss it, how attackers exploit it. We will see a one live demo as well, and then we will cover up how to prevent BOLA. I would say, like at the start of the video, one golden rule whenever you are implementing an API or whenever you're working in any applications, never trust the client to decide what data a user can access. You have to validate, authorize, authenticate everything at your end before you display the data to the user. Nowadays, most modern applications are powered by API, mobile apps, web apps, microservices, cloud platforms. So these are all like the components in modern application. And most data breaches in recent years happen through API and not through traditional web pages. And that is the reason, that is one of the main reason it is in the OWASP API security top 10 vulnerability list as well. And it is right at the top there as well. It's not like API or that vulnerability is not complex, but I think the problem is, or not a problem, but sometimes developer confuse it with the confidentiality. So I think what I can do is, like I will quickly do a comparison between authentication and authorization first, and then we can go deep into the BOLA. Authentication is the one where, just taking an example, for example, you are logging in into an application. You provide your username, password, and then you have implemented the second factor of authentication as well. So once user logged in, you compare the username and password with the saved username and password and make sure like they both matches. If it matches, that means it's the right user who can logging into this application. So that's what we call the authentication. Uh, what comes after authentication is authorization. You have to look into the user and see what action this user can perform. Is this user is a read-only user, or this user can update the inventory if you're building in an app like inventory store. If you're logging into your banking application, just to make sure like this user get an access to his own bank account, not someone else. So that is we call the authorization. Authorization always come after authentication. And in authorization, one of the key concept is, whenever you get a request via API or via front end, you have to double check like the request I'm getting for the logged in user, is this user can perform this action or not. That is like kind of a pretty much what authorization and authentication is. Um, and then the key thing is over here, why, like if it looks so simple, like why developer miss it, why they didn't fix it. um, Sometimes like the developers rely mostly on the front end filters. They thought like once the user is logged in, once we authorized it, then this user can perform an action. They didn't realize, like a middleman can intercept the traffic and send some information or call some APIs which the logged in user is not authorized to do that one. So again, like backend trust the front end filters, missing ownership checks. Microservices assume like upstream auth is enough, which I just explained. Believing like whatever coming is the authenticated and authorized. So the next comes up like how attackers exploit BOLA. Attackers obviously enumerate the IDs, guess predictable identifiers, automate requests, harvest sensitive data silently. Um, After this one, we will look into one practical example as well, and I will explain all this stuff over there as well. But like you see, like it's kind of like a very dangerous. You don't see any brute force attack on your application. You don't see any malware or any alerts. The traffic just looks like a legitimate traffic, just intercepting the traffic, passing someone else's ID, and see what system performs. Or sometimes, um, for example, there is an API which can list the users. You can change that API to get the list of um, all the user IDs, so that later on you can call different APIs to get the user personal information or any sensitive data related to the user. Now let's have a look the practical example. Let me share my screen and then we can go through it together. Let's dive into the practical example and have a look like how this whole scenario works. So you have an API clients over here, which calls an API by passing the ID. And then let's consider like there's a company that has developed a platform to host online shopping application for businesses. So each shopping app has its own admin and a user base. API methods that are available for admin cannot be accessed by the user. So that is pretty simple. And then the admin interface of those shopping apps is implemented in such a way that every request needs an ID of the certain shopping app, whoever trying to access the system. And that is what is you can see on the right of this screen as well. Now let's have a look. So from the hacker perspective, like he was monitoring a bug bounty program. So when he saw an announcement from a company where they invited security researchers to test their updated API, so Bob decided to check whether this newly released functionality had any vulnerabilities he could exploit for his own gain. What he did is like he registered an account and set up a sample shopping app and loaded a test data, users and codes and all that stuff in it. Like that is pretty simple. Um, and then and then he start intercepting the traffic which is from the shopping app. And then like when he clicked on over here, you see like the is intercepting the proxy details, and that's where you have the application interface. So if I click on the customers, now you can see that request as like an API admin shops, uh, IDE and user. So what this API do is like it will return the list of all users for that specific ID. So that is like kind of a hint to the hacker, like, okay, if I pass someone else ID, I can get the list of users. So what he did is, like he set it up another account. The hacker did another account just to prove his concept. Like if he passed anyone else ID, he can get an information. And then let's paste it over here. See what happened. Here you go. So he created two accounts. Using his first account, passing the ID of second account, he will be able to see all the list of all the users over here. So what does this mean is, like that mean the this API, which is admin shops API endpoint, is vulnerable to BOLA attack. And then let's have a look the code that is responsible for authorization functionality of API admin shops endpoint. Let me show you one thing. So this retrieve all user, like this presented control method returns a list of users of the shop with a specific ID. And then, like the controller uses shop user service to load the user that belongs to the shop with the specific ID and return the loaded list, which is kind of a pretty standard, procedure. Now let's have a look. So now, like the detected vulnerability open a possibility for hacker to steal user bases, like containing user personal identifiable information, among other some of the data, of the shopping app. But there's a one question comes in, like you need to pass the IDE and that something you cannot guess. So how you can get the IDs, um, which is it's kind of like a big thing in this one, how to get an ID. So shop IDs likely not like a secret, so they can be retrieved somewhere else in an API. So the thing which Checker did is to find a necessary endpoint. So he start browsing the app to see if he can get an endpoint where he can get the IDs of all the shops. Let's have a look and see if that works or not. Let me click on digital goods. Okay, so the hacker intercept the response of the platform containing the JSON with the list of shopping apps, which you can see it over here. He notices that it also contains the IDs. So that is an ID that are not displayed on the UI, but when you call this API, it gives you the IDs for all the shops that are registered on this platform. So here you can copy the ID, paste it in the list, like the users get users endpoint, and then thereon you can get all the user information, which shows like this application is vulnerable to BOLA attack, and you can exploit it. Now let's have a look this .NET example. So in this example, mitigate the vulnerability on the repository level by checking first if the current user is an administrator of the shop with the provided ID. So before loading the list of the users, there is an additional step of checking that the current authenticated user is among the administrator of the shops with the user defined ID. That is pretty simple. And again, like it's done by loading the list of administrator from the DB of the shop and checking that the current user is in that list. That makes sense. If the user is not in the list, 401 unauthorized response is returned. So that is kind of like a pretty basic, when we talk about authentication, authorization, that's practically, like the thing we always focusing on. Like obviously you can authenticate the user, but authorization is equally important. You cannot rely on the authentication, and you cannot rely on the front end. You cannot rely on your upper layers. So you have to treat each request individually. Cool. And then if we again, by fixing those small things, you can, like this controller over here loads the object with specific ID and retrieve the current user. Before returning the node, the controller checks if the owner of the node is the current user. And then, if current user is not the owner of the API, returns 401 unauthorized. So that's where you authorized the user to make sure this user has the right access to get that information. Now let's come to the point, how to prevent this BOLA attack. It's pretty easy to implement. It's just sometimes as a developer, they rely on the one of the upper layers, say like if the request come to us, that is already authenticated, which is fine, like that request is already authenticated, but you have to enforce the authorization on every request. Check the object ownership, not just the role. Avoid exposing sequential IDs. Like in this example, when we looked into it, you can get the list of all the shop IDs. So there is no need to show those IDs. And again, you can implement the policy-based authorization, validate access at service level, not at UI level, and then obviously log access to the sensitive objects. I said one thing earlier in my at the start of the video, which I would like to emphasize over here now again. So the golden rule is, never trust the client to decide what data a user can access. So you have to verify whenever the request comes, is this user is authorized to get this information or not. Hopefully this video, you find this video helpful. If you like it, please press the subscribe button and press the bell icon to get alerts whenever I post a new video. Thank you.